Hello and welcome to section 5.11, where we talk a little bit about um, a new naming convention for alkenes. That is C double bond C type molecules. So this kind of all started whenever we were looking at the Haworth projections on cyclohexanes. There we are. And we said that in Haworth projections, you could have things either on the same side or things on the opposite side of the bond that's coming out at you here, right? And for stuff on the same side of this imaginary line here, we said that those were in a cis relationship, and those on the other side, we called that trans. In the same lesson in your book, we kind of extended this exact same idea to double bond molecules as well. Where the cis looks very similar, except now our imaginary line is the double bond. And for the trans, it looks sort of like this. And this works pretty well for di-substituted double bond molecules, di-substituted alkenes, but it doesn't work very well for tri and tetra-substituted molecules because if you have a molecule that looks like this, and you have a look at our imaginary line again, it looks like there's something on the same side and something on opposite sides. And you can't have both cis and trans at the same time here in this naming convention. So we needed to have a different way to describe what was happening here. So instead of looking at just one thing and the other and deciding if they're on the same side, what we're going to do is kind of like what we did for the chiral molecules and the CIP naming configuration. Because now, let's say for instance, we're trying to name this molecule. We have an ethyl group and a methyl group on one side. On the other side, we have this oxygen-containing group here. So what you do in this new name convention first is you kind of separate each side of the double bond into its own little box. And so from here, then you just determine priority as you would have for the CIP naming convention, which would mean that the number one priority on the left is with the ethyl group, and the number one priority on the right is with the oxygen-containing group. So now you look at whether they're on the same side of our imaginary double bond or not. And they are on the same side, so we would call this Z. Okay? If they were on the opposite side, we'll just draw it here real fast. If they were on the opposite side, we would call that E instead. And hopefully you see that with these two in the boxes, the number one priority on the left is still the ethyl group, the number one priority on the right is still the oxygen group, and they are on different sides of our imaginary line here, which makes it E here. And it seems like a really weird convention, E and Z, except that this was come up, the idea for this was invented by a German chemist a long time ago. And so, being a German chemist and it being a long time ago, there wasn't a necessity for this chemist to learn English. So he used his German to make a very a very easy to, or like a very simple uh, simple naming convention for them, but for us it doesn't seem so simple. So Z stands for zusammen, which means same in German, and E stands for entgegen, which means different. So if your two highest priority groups are on the same side, the same side, then it is Z for zusammen. But if they're on different sides, like this, then it is E for different or entgegen. So Z, same. That's typically how I remember it. And this has been section 5.11.